Hi ladies, today we're going to talk about percent composition. So percent composition tells you what percent of a compound comes from each of the elements that make it up. So another way to talk about that is to call it mass percent. So the formula for percent composition, which is going to sound a little odd until we do an actual example, right? So the formula is the mass of the element present in 1 mole of the compound divided by the molar mass of the compound times 100%. So all of the percents have to add up to 100 if you do a calculation for all of the percents of the elements in the compound. So let's try an example. So first we're going to start with C2H5OH. Okay, and the first thing that you want to do is calculate the molar mass. So let's figure out how many of each element we have. All right, so we have 2 C's, we have 5 H's plus this H. So we're going to go ahead and call that 6 H's. And then we have 1 O. All right, so now we're going to calculate this, right? Just like we would calculate a molar mass. And then we have 6 times 1. And then we have the 1 times 16. All right, so we're going to add that up. And we get 46 grams per mole. All right, now what we want to do is to calculate percent C. We are going to take our 2 times 12, right, which is 24, and then we're going to divide by 46 times 100, okay? Then we're going to do the same thing for our H's, so we're going to take our 6 times 1, divide by 46 times 100. All right, now we want to do the same thing for our O. So we have 1 times 16 divided by 46 times 100. Right, and what that's doing is that's letting us know, all right, what percent of this 46 grams per mole comes from each of those individual elements. So whatever mass, right, came from carbon to be added together to be to end up in that 46, we want to figure out what percent that is. So let's do our calculations here. So we have 24, which is 2 times 12, divided by 46, times 100, and I'm going to round to 1 decimal place, and I get 52.2%. All right, now I'm going to calculate my H, my percent hydrogen. So I get 6 divided by 46 times 100 gives me 13.0%. And then I have 16 divided by 46. This is my percent oxygen times 100, and I get 34.8%. So now I want to add all of those percents up, right? My 52.2 plus 13 plus 34.8, because I want to make sure they add up to 100. And they do. Okay, so this is my percent composition of C2H5OH. It is 52.2% carbon, 13% hydrogen, and 34.8% oxygen. Okay, so now we're going to try NH3. We're going to do the same thing. We're going to calculate the molar mass, right? So I have 1 nitrogen, which is 1 times 14. And then I have 3 hydrogens, which is 3 times 1. So that gives me 17.0 grams per mole. Now I am going to want to figure out, right, where what percent of that 17, comes from my nitrogen. So I'm going to do 14.0 divided by 17.0 times 100. And then for my hydrogen, I'm going to do 3 times 1, which is 3.0 divided by 17.0 times 100. Okay, let's see what those come out to be. So 14 divided by 17 times 100. Round to 1 decimal place, I get 82.4%. And then 3 divided by 17, I get, times 100, I get 17.6%. Okay, so this is ammonia, NH3, and it is 82.4% nitrogen and 17.6% hydrogen. All right, so let's look at a different type of percent composition problem, but it's really the same idea, right? You're trying to figure out what percent of the total mass will come from each of those individual compounds. So this is when I'm given mass data in a problem. It's a little different than basing it on the chemical formula and the molar mass, but this is telling me a 13.6 gram sample of magnesium oxide is decomposed. 5.40 grams of oxygen is obtained. What is the percent composition of each element in this compound? Okay, so what this is telling me is that I have a total compound, magnesium oxide. So it only can consist of two elements, magnesium and oxygen. So total mass equals 13.60 grams. So it's saying this decomposes. So when it decomposes, that means it breaks down. It can only break down into two elements, oxygen and magnesium. So it's telling me that 5.40 grams comes from oxygen. So let's say mass of O equals 5.40 grams. All right, so how do I figure out how much mass of magnesium I have? I have to subtract these two. So 13.60 minus 5.40, and I get 8.20 grams. Okay, so now we want to figure out what percent of this total mass of the compound comes from each of the individual elements. So my percent magnesium is going to be, that's not a great looking percent sign, but 8.20 divided by 13.60 times 100. And then my percent oxygen is going to be 5.40 divided by 13.60 times 100. And let's see what we get there. So 8.2 divided by 13.6 times 100 gives me 60.3%. And then oxygen, I have 5.4 divided by 13.6, and I get 39.7%. Happen there. So, right, my magnesium oxide, when it decomposed, right, it decomposed into magnesium and oxygen, and it allowed me to see what percent of that compound comes from each element. So I have 60.3% magnesium and 39.7% oxygen. Okay, so those are just two different ways of looking at percent composition. Number one would be if you're given the chemical formula, and number two would be if you're given mass data in a problem. So I hope this helps. If you have any questions, as usual, feel free to reach out or come see me in person. Thanks a lot.